Welcome to another GCBASIC demonstration. This is part 2 of GCBASIC for the 18xxQ20 chip family. Hello, my name is Venn. I'm the lead developer of GCBASIC. I need you to like the video, let it play all the way through. That's very important, even if you don't listen to it. And I need you to like the channel. That will help the channel. Let's get cracking. So what we're doing today is going to make 4 LEDs flash in sequence. We're building upon what we did yesterday in the previous video. What I've got here, I'm going to show you in a moment, is prototype board. I'm using 5 volts. I have a programmer, happens to be a PIC18xxQ20 using PIC18xxQ Plus software. And I've got some LEDs attached via registers. And I've got it wired up using the following. Essentially, I have got 4 LEDs attached to port C, and they're attached to these ports here. That's 7, 6, 5, and 4. They're different color LEDs, and they look like this. Here we go. Green. The blue is flashing at the moment. That's where we left it yesterday. There's a green LED, a yellow LED, and a red LED. And we're going to make those flash in sequence today. This is the Q20. This is the programming cable to the PIC18xxQ2 that's sitting here, just to prove you can do it. And we're just going to make those LEDs flash a couple of ways. So what we're actually going to be doing, I'll go back to the PowerPoint, is we're going to make these LEDs flash in sequence, and we're going to initialize it. We're going to set the first LED, then we're going to have a small delay, and then we're going to rotate the LEDs, and we're going to rotate them to the left. Okay, I'll explain that in a moment. And we're going to figure out whether it overflowed, whether it set a particular bit in the microcontroller, and if it did not, it will just loop back and do it all again. And if it did overflow, it will then reset the first LED and proceed again and go around. So we're just going to see the LEDs rotate in sequence, it's called. So what's it look like? Let me walk you through. We're going to set the first LED on. That's LED 4, C.4, and if you look at the top right-hand corner there, you can see a little LED that's on. Then it will rotate it to the left, and that next LED will come on. Left, the next LED will come on. Left, the next LED will come on. But when you rotate it the next time, it will set the carry flag. Because where's it gone? It's gone into the carry flag. We can test for that carry flag. If the carry flag or a bit that's called sreg.0 has been set, we can restart the sequence. And when we restart the sequence, we can go back to LED 4 and just repeat and repeat and repeat. It's very, very simple. Let's have a look at what that looks like in terms of the code. Let me just pop out to GC Code. This is GC Code, the editor, or IDE as you may call it. I don't care what you call it, but it does what it does. And here we go. I'm going to open up the folder that I was working in. File, open folder, and the folder that I'm working in, or actually I can go back to my recent folders, is I'm working in the vendor boards, Great Cow Basic Demo Board 180FQ20. And in there was where the programs are relative to this demonstration suite. On the left here, I've got all the files. I can open and close that file listing by pressing Control B. I can filter that window just to get my source programs. Control F in here, Control F, GCB, type that in. I'll zoom in on that for you. GCB, and set the filter by hitting that little down arrow, and now it just lists the programs we're interested in. So here we go. Yesterday we finished at 30. Today we're going to do 40 and 41, which is rotate the LEDs. I will delete 42 in a moment. So let's have a look what's going on at 40. It's a relatively simple program. I will load in 41 as well. There we go. 2 programs loaded. Control B to get rid of the file list. I'm back in 40. So same as yesterday, I set the chip F16 PIC18xxQ20, 64 megahertz. Don't, and that is set by default. Option explicit, and I will drill back into that later on. Here's my little diagram of my layout, my 4 LEDs. Touched on this yesterday. If you want to refer to the LEDs, best to use constants. So I've defined 4 constants: LED 7, 6, LED 5, LED 4, and I then set it to the various ports that they are set on. And it's useful to have that, and we'll develop that as we move through the suite of programs. But I also set another one called LED port, called LAT-C. And these are registers and bits that exist in this chip. And I'll show you how I know those exist in a moment. I set all the LEDs to out. Set the ports, okay, to out. Now, what I'm going to do is I'm going to set one of the LEDs on. That's LED 4. Wait for 1 second. Then I'm going to rotate the port to the left, the whole port, port C. I could actually change that LED to, I'll change that constant to our LED port. It's going to rotate those to the left. And if the carry is equal to 1, it's going to set LED 4 back to 1. It's doing what we saw in the presentation. Let's recap. It's going to do it forever. It's going to wait. It's going to rotate the LED's port to the left, moving the value of that bit to the left. And if it's carried, reset the sequence. See if it compiles. Press function key F4, then make hex, and we'll see it's done its stuff, which is great. Look, it's done its stuff, and it's done that in 18 lines of code. It's done it in 5 bytes of RAM. Fantastic. But it didn't program it. So let's just press function key F4, flash. I will then flash the chip, disk cam. Slightly out of sequence. There we go. Just flashing that as it's, and it's just settling 1, 2, 3. LED 4, 5, 6, 7. 4, 5, 6, and 7. Now, what GCBASIC has done, it calculates a 1 second delay automatically. So if I change the frequency of the chip to very low frequency of maybe 1, reprogram it, you will see that the delay is still 1 second because GCBASIC calculates delays automatically. It's now programming it, flashing the LEDs. The time is the same. So it's great. Very simply, in a very simple piece of code, you've been able to rotate the LEDs. It's essentially set the first one, wait, rotate it, reset it when the carry flows. Very simple. Let's look at the same in assembly language. Let's just delve into that for a minute because we can do the same in assembly, but the difficulty about assembly will become very apparent. Let's just look it working first. I'm going to press function key F5. It's going to compile it. It's going to program it. We're going to look at the camera. And we can see it's doing something very similar, slightly different timings, but we'll see why in a moment. See what we've got in our code. Well, we've got the same chip, option explicit. They're the same. We've got some variables being created. We didn't have variables in our original program because they're automatically created for you. Now we're going into the mystery of assembler. It says, set port C to 0. Take the value of hexadecimal 10 and place it in a variable called display that we previously had defined. Boy, this is getting tough. Move the F register into the display, copy display to the LEDs. So these two commands here. So it moves the display value into the register W, then it moves W file register into port C. It then has a delay that's been calculated. That calculation of delay 1 means that it will loop through 255 times and 255 times, and it will do a fixed loop. But this loop is fixed, and it's dependent upon the chip frequency, and the chip frequency is set to 4. So if you change that from 4, and we'll have a look at what the impact is shortly. It then says, ensure the carry bit is clear. Rotate it to the right. Did it rotate? Oh, that should be left. I rotated this. I only wrote this assembly about half an hour ago. Rotate the variable displayed to the left. Did the bit rotate into the carry? If it did, put it into bit 4. We're using variables, and it's not portable code. So let me explain. You cannot put this into a 16F chip. You can't put it into an AVR. You can with the original program that we saw. This program works fine, but this is complex compared to what we saw previously. Let's just change the frequency here to 64. Program it. We can see the timing here. It's every 0.2 of a second. Now we've changed the frequency to 64. It's fast, very fast, because you'd have to recalculate all the delays manually. So one of the advantages of GCBASIC is that these calculations are done. A lot of those types of calculations are simplified within this simple command of the wait command. So let's zoom in on that for you, like I just did. This is the same assembler. It generates the same assembler, but it's not complex. But what I have shown you is that we can easily rotate some variables. We can easily understand the program, but you could also do it in assembler, because it will do both. Let me program up this piece of code here, and we'll change the frequency. In this code, I did already. I set it to 1. I'll put that back to 64 just for the demonstration so you can download them. And now if you look back at this cam, we've got a delay. Great. So what I've shown you and wanted to show you is how to rotate 4 LEDs using relatively simple code. A set of constants. That's not really that hard to do. Set the initial LED, loop forever, and just rotate, checking the C register. C bit, sorry. Let's go back to our slides. So this is the continuing deck of slides and training material for the PIC18xxQ20 series. Tomorrow, next video, we will sequence the LEDs with an LED in terms of the delay coming from the ADC channel. Should be exciting, because we're going to actually take the code we've taken already and expand that to use the ADC as the delay function. And with that, we'll call it a wrap.